Okay, let's start off class with proving to me you know what the heck's been going on in this unit. 2 review questions, part A and part B. Go ahead, see if you can do them. This is just basic find a side length using side, cosine, tangent. All right, ready to roll? Part A, what ratio did you use? 7, what ratio did you use for part A?
Cosine.
Cosine, absolutely. We should add cosine 54 equals 4.5 over x. And rounding to the nearest tenth of a mile, x should have been 5? 7.7. Again, I'm get in the habit if you're not already. I have units here. I have units on my answer. Miles. Next, part B. Let me just, before I call on somebody here, when you have a part A and a part B or a part C and so on question, if you use your answer from a previous part, please use the non-rounded answer. Okay, so for instance, if you try to do part B using Pythag, don't use 7.7 squared, use 7 point whatever it was in your calculator squared. All right, it just use the non-rounded answer at all times. All right, maybe you didn't. What'd you do to find part B? Let's hear from 17.
I used
Tangent, that's fine. You could have used Pythag. You could have also used sine now that you had this value. Tangent of 54. I'll say y now over 4.5. I don't want to say x, different ones. And to the nearest tenth of a mile again, what did we end up with? Hey, 9? 6.2 miles. Guys are on fire. Anything else I can answer on those two? Again, if you're going to use an answer from a previous part, please use the non-rounded answer. I'm actually shocked in this class. You guys are very observant. You ask great questions. I am actually shocked this question has not come up. And that is, why are we always finding sides? Have we ever found an angle yet? No, we have always given an angle. And that's today's topic is, all right, how can I use sine, cosine, and tangent to find an angle measure now? Okay, to find an angle measure. I want you guys to do the same exact steps you've been doing. Do the same exact steps you've been doing. So here we go, problem 1. Everyone sees the angle I'm trying to find. Tell me what the 12 and 24 are. All right, you know what the angle is. We're looking at angle X, trying to find it. So what's the 12 and the 24 here? Let's start with 19. What's the 12? Good. And what's the 24 side? 6?
The adjacent. Wait, what were you asking?
The side that's labeled 24 feet is the what? The hypotenuse. Don't change anything yet. Don't change anything yet. I got adjacent and hypotenuse, so what ratio should I be using? 5? Cosine, yep. So everyone ready? Cosine. We usually put a degree measure there, but now we're going to put what? What is my degree measure? X, yeah. X equals adjacent 12 over hypotenuse 24. Has anything changed yet? Nothing until now. Here's where we stop. We can't cross multiply here. Well, I'll do it. Watch. It doesn't make any sense. Cosine x times 24 equals 12. How are you going to get x by itself? Don't say divide by cosine 24. That's not even there. So everyone see, this doesn't make sense to cross multiply. Whoops. One more. There we go. All right, so here's what we need to do. We're in charge of what angle has a cosine ratio of 12 over 24. We're kind of going in reverse. So we're going to let the calculator still do the work. We got to ask the calculator, here's 12 over 24. Give me an angle where that's the cosine ratio. And how do I do that on the calculator? Everyone take a look at your calculator. Look at your sine, cosine, and tangent buttons. Do you see what's written right above there? Where it says sine to the -1, cosine? That's called inverse. And that's what we need to do to find the angle. So in this problem, we're going to say the angle is equal to the inverse of cosine 12 over 24. We're going to actually ask the calculator, hey, calculator, what angle has a cosine of 12 over 24? So you can do it with me, or if you're already moving ahead, second cosine, 12 over 24. So you're asking the calculator what angle exists that has a cosine ratio of 12 over 24, and it says, hey, I got your back, 60 degrees. That is only for finding an angle. Find a side, I cross multiply. Find an angle, I got to do inverse. All right, have to do inverse. Yes, Quan?
Can you simplify it and still get the same answer?
1/2? Yeah, it'll still work. 0.5, you want to put 0.5 in? Still work. Yep, doesn't need to be like that. Other questions? All right, 1 doesn't make you great. We need more reps. Let's find angle X in the second problem. Somebody first tell me what the 12 and the 18 are. 21, what's the 12? Opposite, how about the 18? Hypotenuse, good work. So now I should be using which ratio? 12, which ratio should I be using? Sine, good work. Sine of X equals the opposite side 12 or the hypotenuse 18. Ask your calculator, what angle has a sine ratio of 12 over 18? So angle X will be equal to inverse. Let's start using the vocabulary. Inverse sine 12 over 18. And the directions are nearest degree here, so whenever you're ready. 11, nearest degree.
42.
Good. Questions, comments? All right, let's apply it to some quadrilaterals like I've been doing a lot this unit. Rectangle time? Quick review. Can you help me? How do I label this? I know H-I-J-K, I get it. And I put them at the corners, I know. That's what period 2 told me until I finally got to the right answer. How do I label a rectangle or any quadrilateral?
In order?
Okay, in order. Good, Paul. H-I-J-K. What do you mean in order?
Like counterclockwise.
Or clockwise, right? Just don't jump diagonally. Here's a prime example why we need to label it clockwise or counterclockwise. First thing it tells me is Ki equals 32. What's Ki in our appropriately labeled diagram? What is Ki? That's a? You label it wrong, it's a side. That's a problem. Okay, that's why we need to label it clockwise or counterclockwise. So 32 is Ki. Kj 11. Find angle IKJ. I'm going to make it difficult for you still. I told you when we started using sine, cosine, tangent, it's only allowed in right triangles. Where's my right triangle? Oh, it's a rectangle, so you know one of the properties is? All angles are right angles. Good. I'm trying to get it out of you. That's why it's a right triangle, and now you're allowed to use sine, cosine, tangent. All right, going back. What sides do I have now? 17. What side's the 11?
That is adjacent.
And how about the 32?
Hypotenuse.
Yep. And if I have adjacent hypotenuse, everybody, you can use 5. What ratio? Cosine. X equals adjacent over hypotenuse. If you're finding a degree, we inverse it. We don't cross multiply. So x equals inverse cosine 11 over 32. When you're ready, to the nearest degree. 19, nearest degree when you're ready. 70 degrees. Yep, nice job. All right. Everyone all good before I bring some bad news? All good? Nothing wrong with that, Tom. We're good. I go on to the next one. New set of directions. Sorry about this. Actually, I'm not sorry. You're not. Suck it up. Solve the right triangle. I'll let you decide. What do you think I'm going to be asking for here when I say solve this? Solve the triangle. How do you solve a triangle? Jonah?
Find like every angle on every side.
Everything that's missing, you're on the hook for. Everything that's missing, you're on the hook for. Suck it up, Mahmood. I can tell that eye roll already, even behind the mask. So solve the right triangle. Find all missing sides and angles. Yep. It's just not that. It's really not that bad. Oh, for you, you're a math teacher. Where do you want to start? Work smarter, not harder. Work smarter, not harder. Where can we start? What do you want to find first? Hi, Jonathan. You want to find angle B? Okay, that's fine. I thought somebody was going to say the side first, but either way, we're going to have to find an angle, then the side, or the side, then the angle. All right, Jonathan wants angle B. You got it, stud. If we're doing angle B, what's the 21 and the 25 then? Oh, 24. What's the 21? And how about the 25? Good job. So I will be using what ratio to find angle B? 3? Cosine. Good work. Cosine. And you can put an X here. I'm just going to put B for angle B because that's what we're finding. But you can put an X equals 21 over 24. Let's do inverse cosine. Relax. And if you read the directions, any degree measure should be to the nearest degree. So angle B to the nearest degree. 2's 22 when you're ready. Come on, Quan. Best group in the nation there, slacking. What?
Yeah, so just a quick question for angle A. Because we already
Don't even go there. Sit in my hand means I do the teaching. Don't blow up my spot again. Got it? You're ready to blow up the spot. I just mentioned work smarter, not harder. So while we're here, why don't we just go to angle A? I don't need to do sine, cosine, tangent. Shouldn't have to again. Why? What do all the angles add up to? 180, you know 2 of them already. I think we can find the third without doing sine, cosine, tangent, right? 180 minus 33 minus 90. Is that what you're going to tell me?
well, just in the special case, right? Let's say we had 32.5 and I don't know, like 58.5 or something like that.
What are you talking
All right,
about?
so no. So this is 90 degrees, right?
That's what a right angle symbol means, yep.
Yes. Okay. So you said round the angles to the nearest degree.
Yep.
Right. What if both of those, angle A and angle B, had a decimal of 0.5?
Okay.
Wouldn't that add up to 91 degrees?
But it shouldn't come out to be that, or we did something wrong. Or it wouldn't be a triangle then. Like wouldn't match up.
Sure, actually.
Right?
Yeah.
Okay. Any more creative ideas? Okay, thank you. I'll just continue teaching. What's your move for side? We didn't talk about side AC. What's your move for side AC? I could do Pythag, right? You could still do, let's see, what is AC? That's opposite and adjacent. So you still could do, actually, you could do sine, cosine, or tangent too. But if you are, you got to use the non-rounded answer in your problem for whatever side you did or whatever angle you're using. Okay, so whatever angle you're using here, all right, you got to use the non-rounded, which I don't know. Me personally, I try to stay away from that. Why don't we just do Pythag? If we do Pythag, where's the 21 and the 25 going? Oh, 21. Where's the 21 going? 21. Darn right. I'll put it in for A. And where's 25 going there, Al? Yep. And this gets rounded to the nearest tenth when somebody's ready. $24 when you're ready. Thank you. Ooh, solve the triangle. Find everything that's missing. Questions from you guys before we end it here? And then you guys have plenty of time to start the assignment. All right, you got to have a Big Al problem in there, right? Legend, celebrity, in honors geometry. He's going to play, whoa, 18-foot ladder. That's serious, huh? 18-foot ladder, 6 feet from the base of his house. All right. Well, we all know, hopefully, if you want to actually make Big Al's house and a ladder, that's fine. I just know it's going to be a right triangle, so I'll just draw a right triangle. I'm not going to get into creative mode. You saw how that worked yesterday. What's always the ladder here? Hypotenuse, 18-footer. Ooh, where's that 6 going? 6 feet from the base of his house. Where's the 6 feet going? Horizontal or vertical leg?
Horizontal.
Horizontal. Find the degree measure the bottom of the ladder makes with the ground. The ground. One more time. The ground. Hopefully we're finding this bottom angle there. I don't even want to know opposite, adjacent, hypotenuse. I'm tired of it. Just tell me what ratio you got to use here. 11, what ratio? Yep. You guys are on fire here lately, huh? I hear the pencil's getting slammed down, so that must mean we're done with it. Nearest degree? Five when you're ready.
70.
What'd you get in your calculator?
70.5. Oh, 71.
I was just about to mention, Greg, that you yourself have been on fire, but bit my tongue there. Any questions? Before you start, just a heads up. These homework problems are all across the board. It's just not finding an angle. You're going to get elevation, depression again, find a side, and find an angle. So it's all across the board tonight. The one in the packet on the next page deals with the rhombus. We went over the properties yesterday when we did the rhombus problem. There's one other property I want to warn you about that may help you with this one. we said what? Diagonals are perpendicular, they bisect each other, and all sides are equal. Anybody remember one other property about the diagonals of a rhombus that may help you on this problem here? They're perpendicular, they bisect each other, Lauren,
Are they equal?
in a
Oh,
rectangle.
oh, oh.
Ooh, 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 in a rectangle.
Perpendicular. Wait, you said that.
I did say that. They
Never
form
mind,
right
okay.
triangles, yes.
Never mind, I'm kidding. Oh, they bisect an angle.
They bisect the angles they're drawn to, correct. Okay? So that might help you out on that problem. All right, wherever you want to go, work with whoever in your groups, and let's roll. You got packet and bookwork here. Plenty of time to
I
get
asked
lunch
a
done.
lot of dumb questions.
Oh, I better, I want to stop the video, huh?